Hello everyone, I'm Syed Rumaan. I'm currently pursuing my bachelor's degree in Bangalore Institute of Technology. The topic that I will be discussing today is multiplexers using entered variable map. So let's get started. Great. So what are multiplexers? A multiplexer is also referred to as a data selector. Now, what does that mean? It means that it is a device that selects between several analog or digital input signals and forwards the selected input to a single output line. There is another way of defining what a multiplexer is. That is, it is an electronic circuit that takes in multiple inputs and gives out a single output. Now, we must remember that every multiplexer will have 2 power n inputs. Now, this term is very much important. The next thing is, what is n here? N is nothing but the number of select lines. Alright, so what are select lines in the first place? So select lines are nothing but these are responsible for selecting the input lines that are to be sent to the output. Now always remember this while solving problems that 2 power n inputs every multiplexer will have. Okay. Now moving on to the different types of multiplexers based on the number of inputs here. We have 2:1, 4:1, 8:1 and 16:1 multiplexers and so on. Now let us consider this 2, 4, 8 and 16, the first numbers in these ratios, among these ratios. So let me equate this 2 to 2 power n from the previous discussion. Right? What do we understand? We get to know that the value of n is 1. That means that I'll have to make use of a single select line. Let me call that as S0 here. That means I will have a single select line, and how many number of inputs will be there? There will be 2 inputs, I0 and I1. And as we all know that every multiplexer will give out only a single output. So Y will be the only output here. Now the question is, from the previous definition, we understand that the select lines will or are responsible for selecting a particular input and sending that to the output here. How is that going to happen? Let's see. Let's go inside this. And if you go inside it, and this is how it's going to look. Alright. So S0, let's say that is selecting I0. It will send I0 to the output. So when you look for the output, what do you get? You get Y to be as I0. Right? Now, if in case you have been given an 8:1 multiplexer, what will you do? Again, equate 8 to 2 power n. Write 8 in terms of powers of 2, that is 2 power 3. That means the value of n, which is nothing but the number of select lines you must consider, is 3. So, when you look for this diagram of a multiplexer, this is S0, S1, S3. So, how many select lines do we have? We have 3 select lines. And how many number of inputs? We have 7 inputs. Right? Actually, there are 8. Here, I7 doesn't mean 7 inputs. We start with I0. So, I0 to 7, 8 inputs will be there. And as we all know, there's going to be only one single output. Now, for instance, if in case I want the output as I7, the inputs that select lines will consider will be 1, 1, 1. So, they will map to I7 and that will give out as the output. That will be your output. Y is equals to I. Let's move on to our next topic. I would like to mention another thing. Entered variable map can be abbreviated as EVM. So there are other ways of writing down EVM, right? Or you can mention it as MEV or VEM. MEV stands for map entered variable and VEM stands for variant entered map, right? So let's start off with solving the problems here. The problem that has been given to us is construct an 8:1 MUX given a 3 variable, that is A, B, C SOP function. So this is the function that has been given to us, f of A, B, C equal to summation of M 0, 1, 5, 6 and 7. Now let's move on to the solution. The first thing that you must always do is look back to the question here. What is it? 8:1 MUX is what you will be constructing. So write down 8:1 MUX that has been given to us. One data has been given to us. Now, as I had earlier told you, you have to equate 2 power n to 8. So how can 8 be written as 2 power 3? That means the number of select lines will be equal to 3. That means we already have our select lines here, A, B and C. Let me construct the truth table now. We have A, B, C and X. Now you have to write down all these values. Okay, so you have 4 zeros and 4 ones, and then 2 zeros, 2 ones respectively, 1 0 and 1 1. And go back to the function that has been given to you. You have 0, 1, 5, 6 and 7. So corresponding to these values, right? So if it is 0, you'll have ABC as 0. Write down 1 there. If it is 1, you'll have 0, 0, 1. Right? Write down 1 there as well. So for 5 and 6 and 7, do the same. You'll have to write down 1, 1 and 1. Now how will you construct the MUX? This is the diagram for a multiplexer. Okay? This is the diagram for a multiplexer. Alright? Now what you must do is, after constructing it, first things first, you have to write down or draw here how many inputs that you will be giving? 7 inputs. So this is your I0, this is I1, it goes till I7, right? And then these are your select lines, right? So this is your A, this is B, and this is C here. Now the output, as I had already told you, it depends on the select lines. Fine. So if the select line, let's say that it is 0 0 0, it will map to 0 0 and 0. What is the value here? 1. So the output that you will see is X to be as 1. So this goes on, right? Our next problem, that is, we must construct an 8:1 multiplexer given a 4 variable SOP function. In our earlier question, we had only 3 variable SOP function. So what's the difference between those two? Let's now see what is the function that has been given to us. F of ABCD sigma m. So we have 0, 1, 2, 4, 7, 8, 11 and 15. So let's move on to the solution here. Again, go back to the question, 8:1 MUX. So write that down. Equate 8 to 2 power n. So 2 power n is equal to 2 power 3. Number of select lines is equal to 3. But here the number of variables are 4. So I will have to write down the multiplexer or draw the multiplexer in such a way that I will represent any one variable in terms of these 3 variables. Okay, that is, let's move on. I'll try explaining this. You have first make a truth table here, right? You have A, B, C, D and then the output X, right? As usual, enter the values. So A will range from, it'll have 8 zeros and then 8 ones. B, 4 zeros, 4 ones, and then it keeps alternating. Similarly for C, you'll have 2 zeros, 2 ones, and then it keeps on alternating again. D, you'll have 0, 1, 0, 1. Now X, what is given here? 0. So write down 1 here. 4 zeros means it is 0, it is 1. If it is 1, it's supposed to be 3 zeros and 1. The equivalent is supposed to be 3 zeros and 1. You'll have to write down 1 here. And then this goes on. Now once you've finished writing down the values of X here, we will try to represent this function in terms of another variable. How do I do that? You can either choose A, B or C or D, whichever variable you want. Let's look at this here. This is an implementation table. Now, what you do is, you'll have to draw it like that of a schema, but this is a bit different, right? So let's say that this here is your input, the input that you're giving, D bar and D. You're representing this thing in terms of D and D bar. Now this is your ABC. Okay, you'll have I0 till I7. Now, look at this thing. When you have D bar and D, here it is 0 and 1. Now how this implementation table, you have to always write it down starting from 0 and then ending till 15, right? Write that down. Now once you finish writing that down, you will have to go back to your truth table. Okay, you have to go back to the truth table. So when it is 0, the value of X is 1. So you'll have to circle this one. When it is 1, the value of X is also 1 again. So you can circle this entire part. Now when this is circled entirely, when this portion is circled entirely, its equivalent is supposed to be 1. Now, if in case, look at 2 here, there is 1 here. Okay, I'll circle that. But 3 is 0, so you don't have to circle it. Here it is only 2. So what is the corresponding D here? It's supposed to be D bar. So you write down D here. And this goes on. So when it is 4, it is again D bar. When it is 7, look at this. This is 7 here. So what is it corresponding to? It's corresponding to D. So once you've finished writing down all this, you can construct the multiplexer here. This is an 8:1 multiplexer, right? So as usual, you draw the diagram, you write down the inputs, and there's going to be only a single output. And what are the select inputs that you have considered? It is A, B, and C. Now here, when there are 3 zeros, what is it corresponding to? It is corresponding to 1. Here if you go back, right? So 0, 0, 1, what is it? It's going to be D bar. So you write down D bar. And this is how you construct for, and this is how you write down for all the other values. This is supposed to be 0 here, right? This is supposed to be 0. Now what does that mean? If these select lines are mapped to 1, 1, 0, the output that they send will be 0 here as well. So thank you everyone for watching my video.